Okay. Okay. So for example, one, I mean, that's just called the segment addition postulate. Some people abbreviate as SAP.
Yeah.
So that, again, that stands for segment. Geez, can't write. So yeah, just add those two and it becomes 3.1.
Yeah.
Or here, x and 2x together add to 3x, add up to 2x plus 5. So 3x equals 2x plus 5. So that's it's all pretty easy, intuitive stuff. So for here, you have to find a measure of each segment, assume that each figure is not drawn to scale. I mean, just add those two together. That's just,
Huh?
it's not that hard, right? It's just 4.5 centimeters, right? So if you look at number 3,
Yeah.
we're just gonna add those two together.
Indeed.
What will those add up to?
Um. Hold on. 6 point. No,
Use a calculator if you need to.
I don't have a calculator on.
You have a cell phone?
Yeah.
It's calculating a cell phone.
Would that work for this?
Just adding 3.5 to 3/4.
3.55
Right.
to 3/4
What do you get when you do that?
plus 3.75 for 7.25. So 7 1/4.
Will be, oh, so, I'm sorry, say it again.
7 1/4.
7 1/4.
Yeah. Well,
No, you're doing
seven
three,
point
three
two
and a half
five.
plus 3/4.
3.
So 3.5 plus 3/4.
Yeah. Oh.
So 3.5 plus 3/4.
Oh, I did that wrong. Hold on. Let me do that again. 3.5 plus 0.75. 4.25. 4 1/4.
Yeah, good. 4.25, right? Okay. For 4, because these are the same, you gotta split it equally between
Yeah.
WX and XY. So what's that split equally?
Uh, say 3 and 3.
3 and 3. And then how about number 2? So you have 6 and you have 2 and 3/4. So BC is just a difference.
Yeah.
So you guys subtract these two. So you gotta do 6 minus, now 2 and 3/4 is 2.75
Yeah.
because 3/4 is 0.75. So what happens when you subtract those two together?
It'll be 4. I mean 4.25.
3.25.
3.25. Yeah.
All right. So then up here, um, S is between R and T. So it helps to kind of do a drawing. Oh, geez. So that's 5x and 3x.
Yeah.
So an RT, the whole thing is 48, right?
Uh-huh.
Oh, geez. So how would it make an equation with that?
With
So because you have
R, like R plus S equals T.
well, RS, which is what?
5x and 3.
5x
Yeah.
plus what?
Plus 3x
Equals
T
equals the whole thing. How long's the whole thing?
to 8x.
But what number do we have? I just wrote it
48. 48.
exactly because they tell you, right?
Yeah.
So you want to draw. So now go and solve it and tell me what you get when you solve it.
5 times. 5 times.
So 5x plus 3x.
I know. 5 times 3, so that's straight up 15.
No. 5x plus 3x. Not
Yeah.
multiplication. You're
No.
adding. You know how to do
Oh, it's
this,
8x equals
right?
48, and then 8 times 8 is 48.
No,
I would just leave it like that. All right.
no, eight times x equals 48. So what does x
It's
equal?
6, 6. X is
Right.
6.
Yeah, you know this. Okay.
Yeah.
So now let's look at 6. So that's 7x plus 4
Uh-huh.
equals 32. So you just get 4 for that one.
Yeah.
Okay, so you're just going to do the same thing with the other two. Do you have some paper that you can do or that you have in front of you? Just to set, because I want you to set up the equation solving them.
Not exactly right now.
Okay, then tell me how I should set up the equation for number 7.
Oh, you should do that little line thing you do.
Okay, so tell me how I should put my dots.
And then you put your dots
So,
one
so,
to the
so
left,
okay, so what's the one what letter should be in the far left?
6x.
No, letter
Oh, letter R,
R in the middle,
S,
in the far right.
T.
Okay, so now what am I going to put right here for RS? How long is RS? Or what
6x, 6x,
6x? Okay. How about ST?
12x.
Just 12.
Oh, just 12, yeah, and then
And
72.
what's the whole thing?
72.
Okay, so what's my equation?
Um, 6x plus 12 equals 72.
Perfect. Very good. Now solve it. Tell me how to solve it.
Um, hold on, let me think.
Well, you want to get x by itself. So what's the first you
So
should
you
do?
divide 12
Divide 12 or subtract 12?
minus 12 minus 12.
Okay, so you get 60. And then divide by 6, right?
10.
10. Okay, there we go. That's all you got to do. Okay. So now for number 8, um, I keep doing my T's like that. It's weird. How long's the whole thing?
32 or 24.
Right. So it's your equation.
4x plus 4x equals 24.
So is x equal?
X equals, hold on, let's say 8,
8 times what gives you 24?
4,
What's 24 divided by 8?
4.
No.
8. Huh. 24 divided by 8 is 2. That was 24. It's 12. That was 4.
What?
Wait,
How many
oh,
times
3.
8
It's
going?
3. It's
Right.
3.
Are you allowed to use a calculator in your math
Yeah,
class?
yeah.
Okay. And how do you like your teacher this year?
It's
Better than
better than
last year?
last year,
That's
but
good. Okay. Okay.
yeah. I heard the class isn't the hardest, so compared to the other geometry teachers.
Okay. Determine whether each pair of segments is congruent. So as long as they're the same number,
Yeah.
they're congruent.
Yeah.
So so the answer is yes. A, B, and C, D, because they both equal 5. You have the markings here. X, Y, and X, Z. Because these markings are the same, you could set them equal to each other.
Yeah.
So X equals 3. So that now becomes 14 and 14. But this becomes 9 times 3 over 2, which is 13 point, no. Yeah, 13.5. So, okay. So the answer is no. X, Y, and Y, Z are not the same. Because 14 does not equal 13.5. It's close, but not exactly. Here they explain how to find the distance between 2 points on a coordinate plane. And really, if you think about it, this formula I'm not really a big fan of because it could be daunting because there's a lot of letters and stuff and subscripts. Really, it's just Pythagorean theorem if you think about it.
Uh-huh.
Because if I do a coordinate plane here and do a few tick marks, that blends in too much. I don't like that.
Yeah.
Let's do light blue. Here we go. So you're going from -1 to 3, which is a length
Yeah.
of 4. That's a right angle. And you go from y equals 3 to y equals -5, which is 8. I'll call C. And you might remember Pythagorean theorem, a squared plus b squared equals c squared.
Yeah.
So your a is 4, or b could be 4, doesn't really matter. But your legs are 4 and 8, you know. So you get 16 plus 64. So c squared equals 80. So c is root 80. So c is 4 root 5.
Yeah.
Because 80 is 16 times 5.
Yeah. Uh,
So yeah. Okay. So that's that one. Um, so yeah, that's that one there. And then just between 2 points and number line, that's just a difference between them. That's not that hard. Like just
yeah.
count it. That's easy. So looks like you took care of that. Let me just make sure those are correct. Um, so hold on. So you gave the coordinates. I like that. What's the difference between them?
Difference between what coordinates? Oh shit.
So no, it's okay. So basically, how many jumps? 1, 2, 3, 4, 5, 6.
6.
So it's just 6. Or DG,
It's,
how many jumps do I do?
ooh,
1,
7.
2, 3, 4, 5, 6, 7, 8, 9. It's not 7 because you're going from -1 to 8.
Oh yeah.
So you're subtracting the 2,
Yeah.
which is 9. See, AF, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yeah.
Okay. 1, 2, 3.
Yeah.
E.g., 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's just that simple as counting, but also taking the difference, Then AG, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You're going from -9 to 8, so that's 17.
Yeah.
Yeah, so that's what's happening there for that one. So here again, it's the same. It's like you're doing Pythagorean theorem.
Yeah.
So if you work it out, you should get
Uh-huh.
so you get 5.
Uh-huh. Yep. Yeah, this stuff's kind of hard, like kind of new to me.
Yeah, it's just plot the points. That's all.
All right, so
And
we're gonna
4,
put
-2 is right here,
mid 5, 3.
which is pretty close together. So you just have length of 1. So that's √2.
Yeah.
If you do Pythagorean theorem again, that's really all you're doing. But if you want to use a formula, like for example, for 19, you're doing 7 minus -3
Yeah.
because you take a difference of x is squared. Because now you kind of see that, visually what's happening. 8 minus -8 squared.
Yeah.
So that's 10 squares, that's 100. Plus 16 squares, 256. So you have √356. And then here, that's just a weird number, so I'll leave it like that. -2 minus -5.
Yeah.
You're right.
Yeah, I'm good.
So that's 3 squares is 9. Plus 6 squares is 36. So you get √45.
All right.
So you have √2, 5, and of course √356. That's all.
Sounds good.
Yeah. So that's pretty straightforward
Straightforward.
stuff. So it's up to you if you want to do the formula or plotting the points and
Huh?
using Pythagorean theorem. I mean, plotting the points using Pythagorean theorem, it gets you away from memorization and really
Huh?
just is more applying a concept more than anything else. And Pythagorean theorem is one of those rules or formulas that just kind of just sticks with us. Like even people my age who don't do any math, they still remember that, you
Yeah.
know. Um, just because it's been being to us for so many years.
Yeah.
So okay, so that's that. I just want to just take a look at the other document that I'll take care of that later. Actually, it's pipe your mall. That
I
was
don't
the one you just turned
know how
in.
to do this. Yeah, I did it all by myself. So I mean, unless you want to review it.
Yeah, let's just review it, just make sure, just have the
Okay.
recording and make sure it's, so if we still have some time, that we can, and maybe we could end a little early tonight. Um, so a space is like three-dimensional, right? It's kind of like, all around us we have space, right? Like a box and all the stuff you put inside the box. It takes up space, right? Like if you, like my kids have like all these stuffed animals and they, like they have this bin, so that's take up space, right?
Yeah.
So a plane is more two-dimensional. It's kind of like if you have a piece of paper and you're drawing the piece of paper, that's a plane. A line, of course, is straight, and a point is just a dot, right? So space is boundless, three-dimensional set of all points, contains lines and planes. The intersection of two or more geometric figures is a set of
Yeah.
points they have in common. We know that. So name the intersection of plane N and line AE. So it's just they're going to intersect at a point. That's point B. BC and DC obviously have point C is where they meet. Does DC and AE intersect? They do not. It's kind of like if you have give me a sec here. It's kind of like you have two pens,
Yeah.
um, and they're kind of like this, like they just don't touch. They're not
Huh?
necessarily parallel. They're just in space, they just don't touch. So no, or no point in common. I mean, sometimes lines could overlap. That's a
Yeah.
possibility. They may intersect everywhere, but lines will intersect once, never, or all the time. Refer to the figure here. Name the three line segments that intersect at point A. So there's three places to meet here,
And we could
here.
do D, F, C,
Yeah,
or
so GA, DA, and BA. GAB.
yeah.
So plane is kind of like a two-dimensional thing. I mean, you could draw like a triangle if you want. FEH.
Yeah.
Yeah, I mean, it looks like they would only meet at point G or name
Mhm.
line of intersection. Hold on. Oh, sorry, line GH. My bad. Let me redraw that. Actually, let me change colors. So GAB could be thought of like this. I'll go to blue. And the FEH could be thought of like this. So GH is where they intersect. That's what they have in common. And it explains GFE. So we kind of looked at GFE is like this. And HBC, they do. The HE. That's what they have in common. Um, and here, this line can be named as line L. Also, any two of the 3 points on the line can be used to name it AB, AC, or BC. Okay, that's fair. That's just kind of explaining to you. Yeah, because yeah, you call line L, you can just pick any 2 points and just name the line. D, you have to use 3 points that are not they're not linear or they're non-collinear that don't make a line that could that are on the plane and just name it that like ABD or ACD or so on. So name a line that contains A. Yeah, AC that works. And just use a symbol though. That's usually a good idea.
Yeah.
Was another line for line M, BD or DB. Good. Yep. Doesn't have to be alphabetical coordinated point at not an ACE. Good. I agree. Was another name for line L, AC. Good. Name a point not on L or ME. Yep. Okay, good. Yeah, going back to number 3 again, you could have said D as well. That would have counted. Draw and label figure displaying each of the relationship given an example. Yeah, so you just kind of just like so you draw like a rectangle,
Yeah.
call it Q, and then here's AB. I don't know why I did it like that. Let's just do it again. Yeah, very simple. And point P. Yeah, that's all. I don't know why I drew a plane, but I didn't need that actually. Point X is collinear, means they're all just on the same.
Line.
Exactly right. So APX, something like that, right?
Yeah.
Point T is not collinear. Sorry, point Y. So there's TP, and Y is just somewhere off in the under. Line L contains X and Y. Why do I do it like that again? Yeah, that. Yeah, that works. Okay. ACE. That works. Line L. That works. Okay. Good. Good. Name array. Yeah, but you just do it like this. Just draw like that. So starting at B going towards D.
Yeah.
Yeah, that works. Okay. What was that? Name the intersection of the plane in DB. That'd be actually it's just gonna be point C because the line's going through the plane. It's not sitting on it. If it's sitting on it, you can just say the line itself, but so it's point C. That's all. So, but for the most part, your answers are pretty good. So it seems like seems like this is a pretty you know, standard geometry class, nothing too crazy. Um, we do have some resources just to kind of share with you, and then we can probably end a little early tonight. And I think we're meeting again Thursday to do more homework together. Let's see here. Yeah, same time, I believe. No, that's another kid. We're at 7 o'clock, I think.
Sure.
Yeah, cool. All right. The only thing I probably could do is maybe I could like print some stuff tomorrow if there's in, just drop it off your house, so you have it.
Yeah.
Just like materials that are good, like
Or if you could like email it to my mom, we have a printer here and I could just print
sure,
it.
yeah, I could do that too. And I could
Or me, I could also print it. It'll be easier,
yeah,
anything.
or I could share a folder if it might be easier, instead of emailing all these files. But like,
Yeah, that also works. Yeah.
yeah, you can see like, this is because I taught a geometry course so a while back and over the summer, and like you see like it describes what a point is, what a line is, array, a line segment, a plane, kind of all the
Yeah.
same stuff, like just extra practice, which is good.
Yeah.
Um, here's like a chapter one test review. Yeah, he sees all kind of the same stuff again. So this is excellent. This is exactly what we're talking about here. This is good stuff. And then you can see what's on deck. More of the same stuff here. Let's see, it's all stuff we've done already,
Yeah.
right? So it's all good stuff. 1, 3. Yeah, we talked about midpoint, cutting things in half. We kind of talked about that distance, midpoint form. We haven't talked about that, but this form we talked about that.
Yeah.
Yeah, this is good. This is really good. It's like almost a mirror image. We'll be talking about angles eventually. I think that's coming up next. Bisect cut angles in half, acute right, right angles, acute or obtuse. Yes, we won't get into this tonight, but complementary subtary angles, stuff like that. Vertical angles, linear pairs out to 180. Vertical angles are the same.
Yeah.
Um, Equilateral, equal angular, regular. Regular's all the same.
Uh,
Equilateral, all the sides add up. Yeah, so
uh,
regular. Yeah, so those things we'll talk about as well. Perimeter, circumference. Perimeter is like when you have all sides. Areas you multiply the two dimensions, get the space that two-dimensional space is taken up,
yeah.
or two-dimensional diagrams like if you're measuring the area of a floor. Circumference 2 pi r. That's what we have there. Excuse me. Jeez. Yeah, chapter is kind of just all the same stuff we talked about. So I think this is. Do you know when your next test is?
Not this week, but the next week.
Okay, but we're meeting enough time, so we'll make sure
Yep.
we'll have enough
Sounds
support for
good.
that. So yeah, I mean, we could probably. Do you have any other homework or anything else?
No, that's it. Yep.
What class are you taking right now?
For everything.
Sure. Yeah.
Yeah, like I'm taking health, got English, um, what else? Chemistry,
hmm
and we have geometry, then history of genocide.
hmm
Um, what's that sixth period class? Spanish, and then I have a free period. So yeah.
Okay, you have a pretty good. And you have to remind me, you get accommodations.
No.
Oh, you don't. Okay, I thought you did. What science class did you have last year?
Biology.
Uh, so chemistry, by the way, if you need help with that, I also have a
Hmm?
my bachelor's degree is in chemical engineering, and
Really?
I tutor chemistry. So if you ever need help with that, let me know.
All right, sounds good. Yeah.
I'll let your mom know that too.
It seems a bit pretty like it seems like a lot.
It can be. It just depends. What do you guys cover right now in chemistry?
We're right now we're just covering over the basics, like not to like screw around with chemicals and shit. So
Yeah. Okay. So it's lab safety, lab
yeah,
protocols, lab procedures, lab equipment.
yeah.
Okay. Yeah, it'll start getting a little dicey as you get deeper into like balancing equations, solving for like how much if you have a reaction, like how many grams of something you might get. pH is measure of acidity. Maybe you guys will cover that.
I covered that like in
Gases.
my fifth grade or something. Yeah,
Yeah, when you get down to that stuff, I can always help you with it because
yeah, sounds good.
there's a bit of a math involved with that too. So okay, yeah, we'll just do an early. We'll make this a short call time. We'll make up the
All
time
right,
another
sounds good.
time. So cool. Okay, I guess we're all set for tonight.
Have a good night.
Okay, see you. Bye.